So we're calculating the area of a much more complicated region right now compared to what you usually do with just direct integrals. If you were to sketch this, you would understand what I mean, so let's go and do that. You're first talking about these two functions, f of x equal to, let me use blue for that one, equal to 5 minus x squared. That is a concave down parabola because it's minus x squared, with y-intercept equal to positive 5. Yeah, so this is a concave down parabola, this being a 5 right here. Now this other one, I'll use green for it. This is x squared minus 3, so now it's concave upward because it's positive x squared, but it touches the x-axis, or the y-axis, excuse me, at negative 3. That is my shape. Now exactly where these two meet, I don't know yet. I will find out, but I'm being asked for the area, for this purple area right there. Not for the net area, right? Just for the area of this region. I'm not trying to give weight, assign positive or negative weight to each parts of this area. I'm just trying to find the area of this region, plain and simple. So how do I do that? The idea is to subtract the two functions, so to integrate the difference of the two. So you take the top function, and then you subtract the bottom function. And you integrate that. And then the question is, from where to where do you integrate it, right? What are the x values that limit this? And these are them. These 2 points are the x values that bound my region. If I were to continue and make for an x value that's here, I'd be including this area, the order, a function that's in the top, and the one that's in the bottom, they get reversed. So that's not what I want to do. I want to make sure that I bound my region correctly. So I need to find where these two functions intersect. So I make 5 minus x squared equal to x squared minus 3. Move this x squared to the right. Move this 3 to the left. So x squared equal to 4. X equals to plus or minus 2. There are 2 points where these guys intersect. That's minus 2 and that's positive 2. So these are my limits of integration. Integrating that from minus 2 to 2. Now I can just continue and figure out what the answer is. This is minus 2 to 2, the integral of minus 2x squared plus 8, combining like terms. And then if I continue, that is anti-deriving, x cubed over 3 plus 8x, evaluate it from minus 2 to 2. That's the fundamental theorem of calculus. I plug things in, so plug in the 2 to get a minus 2 cubed is 8, so that's 16 over 3 plus 16. Remember, I'm plugging in 2 first, then minus, now plug in negative 2. Negative 2 cubed is negative 8 with a minus 2. That's a positive 16. And then negative 2 times positive 8. That's negative 16. So those will combine. That's a minus 16 over 3 plus, so this with this right here, right? Remember that the 16 has a minus outside that needs to be distributed. You can combine that to get a 32. So in fact, you have a minus 32 over 3 plus 32, and that, if you find a common denominator, multiplying this guy by 3 over 3, that will be a 32 times 3, which is 96, minus 32, so 64 over 3 will be the answer. I may have made small mistakes here and there, but the idea is what matters. Always make sure to sketch your regions carefully. It will show how you're finding the intersection points, and that you start your integral carefully, so that once you get to the end, the starting point is clearly indicated. It's easy to understand where you started